So, back again. The yellow light is now on
Yeah.
all the time. So if we reload the web page, just pressing F5, then we are now in this user interface. The important things are that, as you can see here, the gripper is red. That is because it's not connected to the robot arm at the moment. If we film the robot arm,
This is over here.
yeah. So over here we can see that all of these joints are white,
Okay.
except for the gripper,
Yeah.
that is red.
Yeah.
And that it being red means that it can't connect to it for I would say obvious reasons. It's not there.
Yeah.
Um, so, but the other thing is that the way you unlocked it is simply just by pressing, like here on joints, you have this lock and you press the unlock. Then it says open failsafe locking system and you say open. Now it starts opening the joints and like it takes a little bit.
Mhm.
Okay.
All right.
Now the joints are unlocked. So another thing that took me a while to figure out was that the robot arm has two modes. It has ready mode, which is when the lights are blue, and it has the guiding mode, or typically free moves mode, when the lights are white. The way you switch between these two is by using this e-stop button. So when it's engaged, it's in the guiding mode. I've written free moves because I never changed it from free moves up here. So here it's in free moves, but it is actually guiding mode. So when it's engaged and the lights are white, it is using this guiding mode, whichever of these four it may be. But when it's disengaged, it's in ready mode. And ready mode means that it can take external commands, but only, or it cannot accept external commands. It can run programs, but if you want to control it with the FCI interface, the functor control interface, you have to press this FCI activate FCI, and now it's activated.
Okay.
And that means now the controller box, now the controller box will accept commands from ROS, from its ROS interface. Yes. Now we can go back to the terminal that we had running before. So the ROS master is still running, and we have the ROS launch file with the Franke active inference controller. So if we start that up, then it should just start. Yes. And then we can
Well, what did you just check when you look back?
I checked to see if the robot arm didn't move. So as part of the initialization, like it's just like 2 or 3 lines in the code, I set the initial reference position of the robot arm, like the reference positions to its current position. So like just in case something got messed up or something, then like yeah, I just wanted to be sure.
Okay.
But yeah, that was all I was checking. Now we can launch the other half of the program, the stuff that is running on the laptop. So that happens in MSC underscore workspace up there. Also, it's not necessary to go into that into the workspace. It's just convenient. Let's launch, and then I've like there are many sub packages in on this side of the program, but I've made like a top level package that is just a launch file, and that is a non-real-time launcher, because everything in this computer is happening in non-real-time, and everything in this computer is happening with the real-time operating system. So and there's only one launch file, and that is object detect select predict the launch.
Okay.
And basically what is happening here is that the RQ2 RQT image viewer is displaying the images that are seen by the camera,
Yeah.
and it's overlaying them with the tag detections from the able tag. So there's like a faint outline of April tag 1 over here. It's more visible if we put more April tags in the image. But what is also happening is that Arvis is launched, and here we can see all of the coordinate systems being used by the program. So there's the camera frame and the tag 1 frame, and then all of the frames used by the robot arm.
Okay, so
The frames used by the
down.
the camera frame from the robot arm are a total mess. So don't worry about that right now.
Yeah.
But yeah, as you may also be able to see, is that the camera is pointing the opposite way of the April tag. But the end effector coordinate systems are pointing roughly the same direction as, or like the z-axis. It's RGB. Oh yeah, important point. RGB for X, Y, and Z. So the red is X, green is Y, and blue is Z. Yes, that's so yeah. What's happening here is the camera detects the April tags and then passes the locations on through the pipeline. But as you may have noticed, the robot arm is not going for the April tag right now, and that's because in the node right before, like in the, I think it's in the prediction selector, I determine if because everything is happening in the coordinate frame, coordinate system of the robot arm space, I can say if I see that the April tag's distance from the base is further away than what the robot arm can reach, it will, instead of passing on the detected coordinate, it will pass on some default coordinate, the one that it's going to right now.
Okay.
To like a safe-ish location.
Yeah.
Then as soon as the April tag, or the prediction of the April tag, gets within reach of the robot arm, it will then try and go for that prediction.
Okay.
So, let's do it in a similar safe manner.
That's cool.
That's basically how it works.
Yeah.
And like initially, I was using just the predicted position, and I'm still just using that in task space. But when because the inverse kinematics solver only does inverse kinematics, it doesn't do inverse dynamics. So I'm not using the predicted velocities or anything like that. Yeah. But I'm still from the joint space positions that are generated by the inverse kinematics. I use those to generate velocity references, and in the MRAG I low pass filter both the position reference and velocity reference because the MRAG was a pain in the ass to shoot. But the ASC is yeah, it's fun to play with. Yeah. But the ASC is it didn't require that I low pass filtered the references. It even got a little unstable when I tried.
Yeah.
But what was I? Where was it? What did it come to? What was the next part? It's so much fun.
Yeah.
Oh yes, the velocity references. So when the inverse kinematics calculate a reference position, I differentiate that and generate a velocity reference in joint space. In the AAC, I don't low pass filter it. I just say present position minus previous position divided by the sampling frequency, or sampling time, which is 1 kilohertz, by the way. But in the MRAG, I low pass filter it. Yeah, and when I did that, it did like the MRAG and the ASC got slightly more, I want to say oscillatory. I'm not entirely sure. I have not analyze the adaptation parameters super thoroughly. I just use the plots of the internal dynamics to get them to work. But yeah, so like normally when I just turn on the conveyor belt to pass the APOTEC through, then it would then the AIC would move to right above the APOTEC and slow down. But when I included the velocity reference, it had a tendency to have an overshoot. And the problem with overshoot is that then when it bumps into this stack, then it gets a I want to say torque error because it experiences torques externally that it isn't expecting, and then it freezes. So that's why I instead of using this block as the target itself, I disable the robot arm, pass the APOTEC through to roughly where the robot arm would intercept it, and then I block the APOTEC so that I ensure that it's only the counter predictions that are being used without measurement updates.
Yeah.
Does that make any sense?
Yeah, it does.
Okay. Yeah. And that's also how I made the measurements for the report. I've set put the measurements into the report now, so you can see them. They're not finished, but like the lines and stuff are there.
Okay.
So like it might overshoot and hit the block and stop, but we can try and see it in action now. So it's the conveyor belt is set to 2 right now. So yeah, and now because the common filter's main purpose is to prevent the robot arm obscuring the target from stopping the robot arm, and we can see that the robot arm is tracking the object roughly. So we can see that the robot arm continues because it thinks that the velocity is like it's making it go in that direction. And now when the predictable position went outside of the reach zone of the roller, it went back to its homing position.
Okay.
Also, the reason, like, before I added the velocity reference, I just used this phone block to distance the APOTEC from the conveyor belt as a safety precaution. But now that there was overshoot, especially with the MRAC, but also with the ASC, and now I'm looking at the measurements, the ASC has some pretty wild overshoots as well. But yeah, I added this extra buffering so that when I used was back to save the data and then it was played to play the data again, then it would have a couple of some more centimeters to overshoot with.
Okay.
That's the reason for the very large stack.
Yeah. Okay.
I think that's basically it.